A scenario might include, I'm driving down the street and a pedestrian runs in front of my car. That might be a basic scenario. But there might be thousands of little variations on that. Like maybe I'm driving 30 miles an hour, or I'm driving 35 miles an hour, or it's a short pedestrian or a tall pedestrian, or he's running or he's walking, or it's a dog, or it's on a rainy day, or it's on a curvy road, or so there's all these millions of randomized variations on top of that basic scenario that you could make. So this is another area where we are doing a lot of active development. So we're developing tools for editing scenarios through an interface and then being able to retarget those scenarios to different locations. So we see that as kind of an important use case here. So being able to take a scenario and then maybe randomly varying the road a little bit, changing some angles or making the lanes wider, or changing a signal to a stop sign, or in some cases, the scenario might require a signal, so obviously you can't change it to a stop sign, but there might be other cases where it's less important what exactly is there. And so we're trying to figure out that whole process of how we design scenarios interactively, how we set them up to be randomized, and how do we build the tools for doing that. Yeah, I think I mentioned this. So to do a simulation, there's all these different levels of detail you may want to get into if you're simulating your vehicle. You may want to do a full end-to-end simulation where you're simulating the visual scene that the car sees, render a synthetic image like this. Maybe you render one, maybe you're simulating a car with 4 cameras. We would have to simulate 4 images, feed them into the car. We would also have to simulate things like the LiDAR sensors, the laser sensors, the radar. The typical self-driving car these days will have, maybe 4 to 8 cameras, maybe 1 or 2 LiDAR sensors, probably at least 1 forward radar, possibly side rear radar, very often 6 to 8 short-range ultrasonic parking and sensors like that for detecting nearby objects. So there's a couple, and then plus there's other sensors inside the car like GPS, inertial sensors, wheel encoders, and so there's dozens and dozens of sensors on a car. If you want to do the full end-to-end simulation, you would basically have to simulate all of those sensors and provide spoofed sensor data to the brain of the car to test what it's going to do. Essentially, the car takes all this sensor data as input. It takes cameras and all these other sensors as input, and ultimately the car decides, gas, brake, and steering as output, and maybe a couple other things, but basically gas, brake, steering is the main thing that the brain of the car is deciding on. And so to do this simulation, we first have to spoof all the sensors, pass that into the AI that's being tested. The AI then generates gas, brake, and steering values. Then that needs to get passed through a physics simulation of the actual car physics to move the car forward a 60th of a second or however long, and then do it all over again. And so this is done every 60th of a second or at some rate where we're running the simulation. So typically, this may involve lots of CPUs, lots of machines working together in the cloud. So, depending on the fidelity, maybe a single GPU can render a nice image at 60 frames a second, but if you're simulating 8 cameras, you might need 4 or even 8 GPUs to do it. If you're simulating radar, that can typically take a dedicated CPU or a GPU. If you're simulating lots of LiDAR, that can take a dedicated GPU. So it may take a dozen different computers to simulate a single car if you're trying to simulate it in real time. Or you could use lower fidelity models. It really depends on what exactly you're testing and what you're trying to do. So we're trying to build this end-to-end pipeline that includes all of those capabilities. Some of those we're going to build ourselves. Some of those we're working with other customers. Like there's companies out there that already specialize in vehicle physics simulation, and we don't feel like we're going to invent anything new there. It's a well understood field. There's well trusted companies out there generally, Ford's not going to switch to our vehicle physics if they have a trusted company that they're working with. So we're happy to partner with these other companies that specialize in things like the physics of a single vehicle or the detailed physics of a radar sensor, something that we don't really want to get into ourselves. But the orchestrating of the scenario and the control over the different vehicles and who moves when and who goes where and who, that is more of what we're trying to control, the scenario itself. And you want to be able to randomize things on these scenarios like I mentioned. So these are some of the things you might want to vary in a particular scenario. You can always vary the time of day, change where the sun is. Maybe the sun is shining right in the camera and it causes some glare on the sensors. Maybe things are happening at night, might make pedestrians harder to see. So just by varying the time of day, you get a huge variation. You can certainly vary the weather and things like that. Those are things that are varied in the simulator. You can vary timing properties and vehicle speeds and gaps between cars, and typically gap lengths are important in different simulations. So those are other things that can be varied. With our software, because we can model the roads and we can control the roads, we can vary geometric properties of the roads and surface properties like paint quality, lane widths, angles of roads, all these things can be varied. Not to mention the last thing, we can vary things like what country is this happening in, what state in the US, the signage might change, the markings on the road might change, the rules might change of are you allowed to make a left turn at this intersection might change depending on where, what country you're in. And so, again, we're trying to be very flexible with everything we do to make it nothing is hard coded to be the US, and many of our customers are in Germany and China and Japan. This is just a little slide showing the scenario editor. I'll show you a quick video of this too. So we're trying to build this scenario editor that lets us design a scenario like, okay, maybe I'm driving along here and some car suddenly pulls out in front of me that I didn't see. But we want to be able to play that scenario on this road or on that road or coming this way or going that way or in the middle of an intersection. So that's what I was talking about before about being able to design a scenario once and then retarget it to different areas. So as much as possible, we are trying to design a scenario system that allows us to decouple the scenario from the road network itself, so we can control those things independently. And that's what I have in terms of slides. I'll show you the scenario video.
I'm just trying to think of some of the weird stuff I've seen on news, like a sinkhole in the middle of a road.
Yeah, and there are people that collect databases of scenarios. There's actually several companies in town. There's Lytix and Drive or Smart Drive and a couple other folks in town that make camera systems that go onto trucking fleets, and they monitor, just like they'll be on every FedEx truck, for example. They'll monitor the driver and they'll monitor the outside world, and if the truck gets into a crash, they have the video evidence for legal purposes or whatever. And there's several companies like that that they have thousands of vehicles out there driving all day, every day. They see hundreds of accidents every day.
Oh, yeah.
And they see hundreds of weird situations, a cow in the middle of the road or a sinkhole or something that you just wouldn't expect. And so there's become a market for this collection of scenarios, a collection of these situations, and building databases of these situations for this type of testing purpose, with the goal of ultimately being able to simulate them or rerun them from video. As we talk about, like, virtual simulation is very powerful, but it's not going to replace real-world testing and test tracks. We see it as just augmenting all that stuff. So this is our scenario demo video. This shows, I'll kind of walk through it, but this is all in the same editor, so this runs within the same user interface. You can build a road network and then switch over to the scenario mode, and then it changes the toolbar at the top. You have a different set of tools. You can edit your scenario, and then you can actually go back and edit roads as well in the same tool. So this is placing the hypothetical test vehicle was supposed to start over there and end up over here. We're gonna place a parked vehicle, we'll place a car that's intended to pull out in front of the test vehicle, so he's gonna follow this path. We can set up what we call a trigger. So we're placing that trigger there. When the test vehicle gets to that little lightning bolt, it's gonna trigger the white truck to drive out. So we can set that all up through the UI. We'll set up another school bus that's gonna run through this red light. And he's gonna be going 65 miles an hour through a red light. And we're gonna set him up to trigger over here. So when the test vehicle gets there, it's gonna trigger that. And so here we're gonna run the simulation right in the editor, hypothetically. So the test car's driving here, this guy pulls out in front. Then we get to the intersection, and the school bus is gonna run through. But it's not a really big deal because he's got a whole lane to turn into here. So it's not too close. But then all within the same system, we can pop back into the road editor and actually make changes to the road network. So we'll go in and delete one of these lanes. This is showing all the intersection maneuvers. We're gonna delete that lane, make a slight adjustment to this turn here, just to make it smooth. We can go in and change markings. So this is gonna actually set this to a solid line. So technically you're not allowed to make a lane change over a solid marking. And so that you go, the test car will obey the law. It doesn't absolutely have to, but we choose it to. So you see that popping back into the scenario mode, it's now automatically adjusted the scenario to the road changes. So this guy will now wait till he's past that mark to change lanes. And then we're gonna get to the intersection here. Now that there's no lane to turn into, we'll have just a slightly closer call here. And so this guy will have to kind of hit his brakes there. And so that shows what I was talking about, this ability to build a scenario, run it once, and then run it on a slightly different road network. And in fact, we can run it on a completely different road network. We can actually take this whole scenario and copy it and paste it to a completely different intersection. But I don't have a video of that because that's a little bit more recent technology. Yeah, I think that shows most of it. I got more stuff. If there's any questions or if there's things you want to see in more detail, I can probably show some more stuff, but that gives a basic idea. Did anyone have any questions on this? Yeah.
Are you able to import like a 2D map to kind of help you get started faster?
Yeah, we can import a bunch of different things. It really depends. Typically, you're going to end up having to trace over it unless you actually are importing it from some format that has detailed road lane information. So we can bring in area, this all falls under what's called GIS data. I don't know if you're familiar with that term. GIS stands for Geographic Information Systems or something, but it's a whole multi-billion-dollar industry. It basically is the mapping industry, and there's a bunch of standard GIS forms and GIS data that's available. So for example, Google Earth is a GIS tool. It views map data. So you can, the US Geological Survey publishes map aerial imagery for the whole US. It has elevation data for the whole US. It has LiDAR for much of the US. It's all free, it's government tax dollars at work, so you can go to the US Geological Survey's website and download an aerial image of this neighborhood. And it might be 5 years old, or it might be blurry, or it's not guaranteed to be perfect up to the minute, but you can get that data. And so we'll typically start with a bunch of GIS data. So we'll start with aerial imagery, we'll start with an elevation map, which is often might be at 10-meter resolution, which is pretty coarse. Near the coast, you can get 1-meter resolution elevation data, which is pretty good. We'll bring in whatever data we can. So you can usually get, if you're near the coast, you can usually get good LiDAR data because the coastal, I guess the Coast Guard does LiDAR scans of the coast to do flood modeling and flood preparedness. So all that data is available. So yeah, there's a bunch of map data sources available. We can import, there's a bunch of standard files for this stuff. The nice thing about it is they all have the mapping coordinates built in, the map projection. So you can get a file from the US Geological Survey of some section of road, and then you can load up an elevation map that might be from a totally different source from 5 years earlier, but they should still line up automatically because they'll have the latitude, longitude built into the file according to, there's various GIS standards. So you can bring in all these different data sources, and generally they should line up pretty well. Sometimes you have to fudge them a little, just have a shifted over a meter or something, but there's a lot of data out there, and we can bring in several different kinds of data. There's also OpenStreetMap data, which has vectors of roads, but it's very simplistic. It's really not at the level of quality that we would require, but it does give you kind of a first pass.
So nothing like Street View or anything like that?
Like Google Street View? There are data sources of what we call, that's panoramic imagery. We would refer to it as like a spherical kind of panoramic image. There are data sources for that. There are people that can license you that data. We don't work with that type of data very much, like we'll work with an overhead image that lets you build the map on top of it. That type of imagery for us is more useful if we're placing signs, or if we're trying to understand how the signals are set up in an intersection. So we'll often look at Google just for visual reference, but we generally don't directly use data from Google because you have to. It's
kind of like a final check or something.
yeah, but also. Like we'll bring in all these different data sources that give us the road layout, but they're not going to tell us what is this one, what kind of sign that is over there. You really have to get down to the street level to see warning signs and temporary things like that. So again, whatever data source, the more the better. People always ask us, hey, I have a map of such and such, is that helpful? And yeah, it's helpful. Whatever you got, whatever you can bring in, whatever reference, the more the better. If you have a laser scan down to every millimeter, then great. If you have a very coarse 10-meter elevation map, then that's fine too.
How important is it that you have accurate data? I mean,
It really depends on what you're doing with it at the end.
if you're just running simulations.
Right, if you're running simulations that don't really have to correlate to the real world, then that's fine. But what we find is that customers need 3 different maps of the same area. They need an open drive file, like I mentioned earlier, which is what a lot of simulators take as input, which has the road boundaries and in a curve format. They'll need like an FBX file, which has the detailed textured, colored imagery, and they'll need some kind of navigation map to simulate what the car internally views as its navigation map. And so they actually need 3 different maps of this exact same area that have to line up. Now it could still be an artificial area as long as we can produce all 3 of those formats. So that's been a big thing for us, is conversion of data from one format to another. Like we'll have a map in this format and we'll need to generate it in these other formats. So that's been a big.
What are the main customers for your product?
We've been focusing on the autonomous vehicle market. There are definitely other markets that we see it, but we've been so focused on that market just because it's such a hot market right now, and we're a small company. But we definitely see like urban planning as a whole other industry that we could go into, and like governments all want to maintain maps of their streets and want to have tools for managing that. There are mapping tools out there, but there's really very little for good quality road modeling, and we kind of really have a lot of specialty in that. I did a previous company where we did a city modeling tool. We sold that to Navtech, and then we went and built Navtech maps for years, and then we started this company. So I come from a long mapping background, dealing with roads.
The tool looks amazing. Can I ask, like, how long did it take to get to a point that it was
we started developing it in February 2017.
Okay.
We released the first version in July 2018, so just under a year and a half to get it to a release. That was with people who've done this before, right? Me and the other founders of the company have done this before, and so we were able to just really get it moving very quickly.
What is it, like, what framework did you guys use?
It uses Qt to do the user interface, and we use OpenGL to do all the graphics. Nice. We output to Unity and Unreal, but we don't use either of them in the actual graphics in the editor. And that's, you know, there's a variety of other open source things under the hood. There's a library called GDAL and a library called pt.2. Both of them are GIS related that help with importing a lot of standard file formats and things like that. But there's not a lot of other big, I mean, we've gone through, we probably use 30 pieces of open source software here and there, but the big ones are Qt and GDAL, pdal, and OpenGL. So.
Nice.
How do you make money? Do you sell the tool? Do you sell the simulation? Do you sell the?
We sell the tool itself. It's
Okay.
$12,500 for a license. If anyone wants to buy one, we'll give you a discount. But it's you know, it might sound expensive, but to the customers who buy it, it's they're kind of scratching their head, going, "Well, that's kind of
That's
cheap."
cheap.
Yeah, and you know, General Motors has probably 7 or 8 licenses, and I'll just get random emails from them saying, "Oh yeah, we need one more." And Nvidia just bought 8 licenses, so we got, you know, people buy a decent number. We also do service work, so we'll build out areas for customers.
Okay.
So we'll do that as a service. And we also have a bunch of other tools that we're working on that we're coming out with next year. So the ability to import some of these HD map formats is something that's going to be sold as a separate plugin. And then the simulation, the scenario editing I was showing is not released yet. So that's something that's going to be sold in a very different way. The scenario editor is an interactive editor that requires a person to sit there and use the mouse and edit. But once you've edited your scenario, you can now deploy it in tens of thousands of simulations. We have a scenario player that does that. And so our goal is to sell tens of thousands of copies of the scenario player and only a handful of copies of the editor. So it may eventually get to the point where we're giving the editors away at a very low price or even for free if it means we're selling tens of thousands of copies of the scenario player. So that's kind of the long-term goal, is to get into this cloud deployment, kind of cloud scale.
Are you thinking of like a marketplace where people can create?
Yeah, that's come up many times. Like we already sell our prop kit, which has, you know, different signs and stencils and trees and things like that, and we sell that to, you know, probably 2/3 of the people who buy the editor will buy the prop kit. And we talked to a couple other art companies that make similar building kits and stuff, and
It could be.
I could see that happening. I don't know if it's not like the Unity and Unreal market, which is just massive in comparison. This is
Right.
still a
Very
much
early.
smaller market for that sort of thing. But yeah, I think especially if you're selling functional things like traffic signals that are more than just a 3D model, it has to be configured a certain way to have it actually work. That makes it more sellable from our point of view, because yeah, people can go to TurboSquid and buy, you know, 100 traffic signals for $2, but is it going to light up correctly in our editor? It's going to be the wrong scale, or it's going to be facing this axis, the x-axis, or it's going to be heading this way, you know. So that's one of the nice things about buying our prop kit, is that everything's scaled correctly,
it'll work.
everything's calibrated, you know it's going to work. But yeah, there's definitely a market, and really we're getting to the point where we don't have enough artists to do the service work that we're looking at. Yeah, and so I think there is a potential business for people building environments with our tool. And I have a couple friends I was going to talk to about, hey, I think you should start up a company to take off some of the work that we get to do the service work, because we can't even do that much of it.
And that's not core to your business.
Right, it's not really the core of what we want to do. Selling software is really the core of our business. And the service work is great because it's, you know, when Honda comes to you and wants service work, you know it's going to lead to more, right? So we'll do it for these big companies, but we don't want to get into this, you know, doing tons and tons of environments with it.
Does anyone like ask you to sell like the actual city map? Like, I'm
That's
sure
not really what we're focused on. There are companies that do that, like Here Maps and TomTom, or these larger mapping companies. And really, we haven't built huge areas with the tool. Most of our use case is fairly small environments where the scenario is just, I just gotta get from this side of the intersection to the other side of the intersection. I don't need to drive around in 10 miles through some city to just verify a test. But different customers want to do it different ways, but mostly what we're seeing is these people are interested in these small, lots and lots of small test cases. There's a couple folks we talk to who take the more route of, I have a big map of San Francisco and I just want to drive around and have things happen, you know. But that doesn't seem to be as big of a use case.
What are the good examples of like actual self-driving car can do that it can do better on the simulation?
What are examples of things a car can do better in a
Or
simulation?
like that the on the self-driving cars wants to do it on simulation
It's
over.
really a question of safety things. It's like you can go to a test track and have a robotic pedestrian. I've seen these sort of plastic pedestrians, or they'll even have ones that kind of do this, and it'll be dragging along on somebody will either be pulling a rope or it'll be on a little robotic platform. But it's like you can only do that so much, right? You can't set up complex test cases with that. You can't run it 1,000 times a day. It takes time and money to go out to the test track and do these.
Do you guys
tests.
have people that you can throw
We
into?
have a little bit, but we haven't focused on. That's an area we're also beefing up now is pedestrians. The scenario system we have does allow you to do pedestrians, but we haven't put a lot of energy into that yet. But we want to get all that pedestrians and bicycles and skateboards and everything you might see on the
Dogs.
road. Yeah, dogs and who knows. And again, thinking globally, there's all kinds of weird things that you'll find on the road in different countries. So, the major developments now are definitely kind of the big city urban areas. People care about the Bay Area. People care about Germany, parts of new areas of China. So the areas that are pretty well designed, but as time goes on, it's going to basically be anywhere.
Right.
Yeah.
How big is the company?
We have 14 people.
And you're here in San Diego?
Carlsbad, yeah.
Nice.
I think there's 7 engineers besides me, or maybe there's 8 now, I think 7 or 8. And then we have 3 artists who do the actual art modeling, and then we have a couple sales people, and then 1 support, testing and support.
Can you talk about your transition from gaming company to mapping company to 3D mapping?
So yeah, I worked at Angel Studios from 1992 to 2002. Brad Hunt, who I think comes to this once in a while, was one of the other owners of Angel Studios. And we did video games, some 3D video games, and we worked on some of these city games like Midtown Madness, which took place in an open city. And we built tools internally at Angel Studios to model the roads. Then Brad did a whole bunch of work on that, where we had generated we built like a model of Chicago, a very caricature, cartoony model of Chicago, but for this video game, Midtown Madness, back in the mid-90s. And so yeah, we did traffic simulation, we did vehicle physics, we had similar triggered events like what I'm showing here, where you're driving down the street and the FedEx truck backs out of the driveway at just the right time. And so we had really almost all the same kinds of elements in these video games in the 90s. And we ended up selling that company to Rockstar in 2002, and that's now Rockstar San Diego. And they worked on Grand Theft Auto, but the Rockstar San Diego team mainly works on the Red Dead Revolver, Red Dead Redemption series. And then in 2006, I started this other company, Pixel Active, where the point of Pixel Active was to make city modeling tools, similar to what you see here, but not as nitty-gritty on the roads, but more handling larger cities, handling buildings, more landscape control and water and stuff. And it was originally geared towards games, but we found that for every 1 game company that was interested in the product, there was 20 military or government institutions that were interested in it. And so we we found there was just an overwhelmingly much larger interest in the military and government space in that last company, and we ended up selling the company to Navtech, which was part of Nokia, which then became Here Maps. And now Here Maps is up in Carlsbad, about 2 blocks away from Rockstar, and then we're about 2 blocks away from those as well. So all of us in the same neighborhood. And so yeah, we worked at I worked at Here Maps for a couple of years. The other founders at at Vector Zero worked at Here Maps for a few years. Then we left in 2017 to start Vector Zero. Now we're actually working with Here Maps again, and we're importing their map data, and we're working with them, so trying to keep it friendly with them. So, but yeah, games is a great background for all kinds of other industries that depend on that same technology. I mean, essentially, that's what this is. It's a video game for cars. It's got all the same elements. It's got graphics and physics and timing, and it's a little more strict in terms of requirements in some ways, but it's less strict in terms of, fun is a very difficult thing to build into a video game. And this doesn't have to be fun, it just has to represent the real world at a reasonable enough level. And there's always gonna get more, it's always gonna get better. You can always continue to improve the models and, do pedestrians and do skateboarders, and you can spend years on making the perfect skateboarder physics if you want. You can take any one piece of what we're doing and expand on it tenfold. So we see plenty of additional stuff to do here. And again, we're trying to partner with some companies that do pieces of the puzzle. We're trying to solve pieces of the puzzle ourselves, and eventually build this full pipeline to simulate everything. And then people are already talking about, well, what if we want to simulate interiors, or we want to do robots, or we want to simulate drones, delivery drones. The roads have been our central focus, but really building the 3D world for simulation is a broader, something that could be done as well. Roads have been kind of our bread and butter, but there's obviously, you take it anywhere from there. So I think a lot of people are seeing simulation as the key for the future of robotics, for training robots, for testing them, for verifying safety issues. Simulation is going to play a huge role in all that stuff.
Is there pricing where you can do more on subscription, not the perpetual license?
Yeah, we've been doing a couple subscriptions, but not but at like $1,500 a month or something. I mean, if anyone here had an interest in the product, we could let you play with it for a few weeks or something, or if you had a project in mind, if it's for an academic kind of research purpose. We do have over 50 schools using it, and we give a free license to a school. So again, if someone had an interest, just send me an email and mention where you saw that if you want. But also, there is a free demo version, so you can download that, play around with it. It doesn't let you save or export anything. So if you actually wanted to save or export something, you can get in touch with me, and we can let you play with it for a few weeks or something, maybe a couple of weeks. And if you can actually build something nice with it that, we'll put on a webpage and we'll let you play with it longer.
Excellent.
Any other questions? Okay.
Cool. Thank you very much,
Thank
Steve.
you so much.
Very good.